Today I'm going to show you how you can make your FTC robotics electrical system a lot more reliable and stop cables breaking and stop some of those power cables disconnecting in the middle of a match. So now when I flick it on, I get nice reliable power to both systems. I'm Coach Pratt and I've been teaching robotics and design for over a decade now, and I've mentored FTC teams to winning national championships. And today I'm going to show you how I've swapped and replaced a lot of my XT30 connectors for a different type of connector that makes my robots and my team's robots electrical systems far more reliable and far less likely to have disconnects in the middle of a match. So a lot of teams start off with something like this. You might have seen this connector before. It's a Tamiya connector. It is not a very reliable connector. This little plastic hinge here likes to loosen up over time, so it's pretty easy to just pull these suckers apart. I don't really like them. Another option that is the standard on the control hub is something called an XT30 connector. That's this guy. They're a little more reliable. The problem is trying to connect and unconnect one of these guys is that you really do need to grab really close to the wire. In my experience, what a lot of people do is they just grab the wires here and they pull. This is not a very reliable connector. And the reason being is that it is a soldered joint. And because it is a soldered joint, the more you flex this head and the more you pull on this, you're probably like me, you probably got a cable graveyard from years of doing FTC. We've had to resolder these XT connectors on all the time. My preferred connection is this guy right here. This is an Anderson Powerpole connection, and it's rated for, I believe, several 100,000 clicks in and out. It is a very rock solid connection. It is a crimped connector, so even if people do pull on the wires, it tends to hold a lot better than those soldered connections do, and it's a very solid connection point. It's rated lots, and you will not have this thing come undone on you in the middle of a match. What this also does is this helps save some of your connection points on the control hub itself. So for my robot here, I have modified my switch here. This is a standard rev switch. I've modified this to be Anderson Powerpole connectors so that I can take a fuse battery that I've also swapped an Anderson Powerpole connector onto. This can clip into my battery like so. This then clips into your control hub, and you can switch them on and off. Super reliable connection. Now you might say, hey, Coach, I also have an expansion hub. I'm aware this is a control hub, but I've also got an expansion hub that I'm able to connect to. Well, that's where one of these little guys comes in. This is a power distribution block, and effectively it ties together all of your positives and all of your grounds together. And this makes it a lot more reliable. It also means you no longer have the daisy chain power from a control hub to a expansion hub, make things a lot more reliable. So now you can come from your battery into your switch, go into the main port here on your power hub. And then I like to use a few 30 centimeter power pole to power pole connectors. We can now connect this into our power block or power distribution block and connect these directly into our control hub and expansion hub respectively. And this is how we end up powering our systems together. I also like to have a few extra ports here just in case you want to have a servo power hub or something like that. So now when I flick it on, I get nice reliable power to both systems. Another thing that I like to do is I will grab one of these XT30 to Anderson Powerpole connectors, and I will permanently keep this one mounted into the control or expansion hubs so that I'm always connecting just to this connector here. It helps save the sort of fragileness that is there, because I'm sure that a lot of teams know of having to grab a knife and splitting these, or a really thin slot screwdriver, splitting these, because it ends up being relatively unreliable over time with a lot of different connections, and that is just a friction fit. The last thing that I do is there's a little 3D model from a user on Thingiverse. I'll have it linked in the model description down below that I've forgotten their username, but it's a great little model here in that you have a bottom plate on the bottom and a top plate on the top. You can screw this down, glue the bottom plate to the control hub, and then you can permanently mount this cable down and clamp it onto the XT30 so it's not going to be able to come apart. And you have that. So on almost all of my control hubs, I say almost all because apparently I have some that I haven't updated yet, in that all of my competition hubs have this permanently clamped down with a power pole connector that can then go into the power brick from behind, connect these together, and these things aren't coming apart. It is such a more reliable system, and you don't have to worry about having power or brownouts or spotty connections because these darn XT30s have managed to desolder on you again over time. In fact, you can see on some of these, it's already starting to get pretty darn close. And some of this wiring gets a little bit hairy and a little bit scary. If you're not sure how to crimp your own connectors with Anderson Powerpole, I have a full video on that down below. If you're looking for more code snippets, CAD snippets, extra robotics resource, you can consider joining my community down below or check out some of the other tutorials I've got. I'm curious if your team has already swapped over to Anderson Powerpoles, something like that. If you're not sure where to get all the tools for these things, I'll also have it in the description down below. And as always, best of luck out there this FTC season.